Hey everybody, how you doing? I'm gonna do a video on a pole transformer, like they have up on the telephone pole. Now I did not steal this. I purchased this brand new. Went to a customer, he ended up upgrading, so he sold it back to me, since it was it no longer met his needs. Okay, so first off, this was a new transformer, not a rebuilt transformer. There are a lot of companies out there that mostly just rebuild transformers. They'll buy still working transformers. They'll take them out of the can. They'll clean the can, clean the core, and then fill it back. Put the transformer core back in and fill it back with oil and repaint it and all that. This was brand new. New can, new transformer, new oil, new everything. Second, a lot of the transformers out there, they're still out there. Well, first off, some had PCBs in them. I think it's probably pretty hard to find one with PCBs in it nowadays. But two, a lot of the transformers out there are wound with aluminum. They have some copper, but mostly aluminum. This one was wound with all copper, no aluminum whatsoever. Power company feeds this side in their world. That's the side that's fed from the street. A lot of times they have one bushing on the top instead of two. This is a delta. It's two primaries. In our world, we flip it up, backwards, and that turns into the secondary. And this is the secondary in our world. I'm sorry, primary in our world, secondary in their world. You have the outer two taps, which are 240, and then the center is the center tap. So if you go from one outer to the center, you have 120, or center to the other, 120, same thing. Like I said, across the outers is 240. It's closer to 250 here, but what else? They're good transformers. They're actually wound different. I was told that the windings are backwards. I don't know if this is true. I've never actually dissected a transformer, but I was told that like a conventional transformer here on my bench, I forget, my buddy told me it's backwards. The primary is opposite versus a conventional transformer that I forget if the primary was closer to the center of the core or the secondary was, but it's backwards. These transformers are designed to run most efficient at lower loads versus higher loads, because a lot of times they're sitting on the street, and a lot of when people are at work, a lot of times there's very little to no load on them, and if they're inefficient at low load, then the power company would lose a lot of power, a lot of money in the process. So this one's 25 kVA, 5500 volts. That's that equals out to 4.54 amps. CCS actually has a percentage switch on the side right there, which allowed the power company with the transformer, the pole. See, this was custom wound to this voltage, but this isn't a standard voltage. So more standard would be like 4800, 7200, and so on. So let's say you had a 7200 volt primary and a transformer. They had a little over 7200 volts on the pole. They would change the selection on the switch to either bring down or bring up the voltage on the secondary side in their world. If you buy one of these things, you have to keep it in the oil. I'll provide a link. It's a Wikipedia link. It explains the construction of these transformers. And also, I have another link that I can provide that talks about transformers. The oil not only cools the core, but it's absorbed by the insulating material between the windings, which isn't the same as a conventional transformer. So once all of the oil is gone, even if you're running the transformer at a lower power level, so you're not, trying to suck the max kVA rating out of it, eventually they always end up flashing. It heats up, then the enamel wire, the coating on the wire breaks down the enamel, and they flash. They're just not designed to be out of oil. You cannot run them out of oil. They always end up failing, and it can become dangerous. It can become life-threatening depending on, if the thing were to light on fire, or if the thing's not properly grounded and you're touching it. So I never recommend to people that they ever run a transformer like this out of the oil. The oil increases the dielectric properties between the windings, the coiled, the turns, the transformer turns. It's basically a coil wrapped around a core. So once that happens, once the transformer flashes, it's done. It's shot. It's no good. So if you're going to run one of these, you have to run in the can. See, the insulating material is actually designed to absorb. So if there's no oil, and once all the oil's gone, it will absorb moisture from the air, and then it will end up flashing. These transformers, an oil-filled transformer or a potted transformer, it's where the core is sealed. Like these are conventional transformers. They're not potted, as you can see in there. You can get to the insulation's in there. There's resin in there, but I'm not going to get into that, how they make transformers. But technically, a potted or oil-filled transformer is ideal, since you can put this in, you can leave it outside, you can put it in a damp basement, you can put it anywhere, and you don't have to worry about moisture. See, the problem is, once moisture gets in and it's absorbed by the insulating paper, it's only a matter of time before it arcs. Transformer core is steel, and when you have steel, you have condensation. If you're, like I said, if it's located in a damp environment, or in a environment where there are extreme temperature changes or shifts, like a garage where it can get really hot and it's not insulated, it gets really hot during the day and then really cold at night, just like an engine block, you'll see condensation, and that condensation will build up. This core is on its side, but still water can get in there and drip in there, or if the transformer were flipped like a regular one, where you can see down into the core from the top, you can get in there easier. But once that happens, it's shot. So don't ever get duped into buying a pole transformer that has been taken out of the oil. These are perfectly safe to run in a house. When they're on a telephone pole, you've seen them blow up or whatever. That's because they're overloading the crud out of them. A lot of times they'll have like 5, 6, 7 or more houses on one transformer like this, while it's being just totally overloaded by hundreds of percent. They don't fuse them. A lot of times they're not fused. So they're feeding the primary, which is the secondary in our world, so they're feeding it with an almost unlimited amount of current. Well, there's a fuse way down the street somewhere, but if it ends up failing, if it gets hot enough, the paper breaks down, the insulating paper flashes, then boom, there's nothing to stop it from happening. From everything from going into overload and blowing up or whatever. But in our world, we're feeding the lower voltage side, and there's a circuit breaker. There's no way you can overload one of these. It's not going to happen. In the literature I'll provide, talks about Celsius rise. For every 6 degrees in ambient temperature rise, in core temperature rise, you cut the transformer life in half. For every 6 degrees above whatever whatever its rating is. So I'll provide that. I'll provide that page and the link to it, and you guys can read it. I'm not a transformer expert. I don't claim to be a transformer expert, but I've had a lot of people come in with amplifiers that have had pole transformers in them that were removed out of oil, and you know, it may seem like a good deal. You're buying a transformer for a little bit less money, but you know, what's the point of buying something that's going to end up failing, end up spending more in the long run? I see that all the time. People will buy an amplifier or a transformer or whatever it may be. They think they're saving a few bucks, but then they end up just dumping so much money into it, and then they're down and a lot, and they can't enjoy their equipment. They have to deal with all the BS, the weight, and all that stuff, you know, when they're bringing it to other people or whatever. But I hate being the bearer of bad news, but it seems to happen a lot. So I figured I would make a short video, and that's what I'm doing. And these are great transformers. You know, if you have a spot for it, you know, they may have just a hair more sag than a conventional, but you can get a lot more transformer for a lot less money. For what this cost, I could get a transformer half the size, literally half. This transformer is rated for 2.5 amps CCS, and this one's rated for just under 5 amps. I got a quote for a new one like this, and it was about 1,300 something bucks before shipping. That's actually more than what this cost. So, and this, you know, this is about half. I mean, this is about double. It's about double the size. So, it doesn't take a rocket scientist to figure out what, you know, makes more sense to go with. But perfectly safe, you know, to run. You just, you know, just like regular transformer. It's in oil. So sealed from moisture, within a can. You can make your connections and put PVC tube over it, and no one can touch it. Tape up the primary side, whatever. Perfectly safe to have in a house. But I'd recommend staying away from older ones that have been rebuilt. Just go buy a brand new one with copper windings. You can get them wound to whatever voltage you want. Just definitely don't ever take it out of the oil. So, yeah. So I'm sure there'll be critics that watch this and pick apart some of my technical stuff I said. But like I said, I'll provide the links and a picture of each page that can back up what I've said. So here. Hey, thanks for watching. Many more videos to come.